Okay, so this is the talk on inside Word, Excel and PowerPoint documents, a developer's perspective, which was my attempt to create the longest title in the whole of DevWeek. Probably leaves a few people wondering what I'm actually going to talk about, but it is actually what it says. I'm going to start diving inside the documents, the files that Word, Excel and PowerPoint produce, using something called the Office OpenXML framework. So I'll just start with the usual obligatory who on earth am I? Obviously it's Simon Robinson, blog at techiesimon.com. I was a C++ developer in the 1990s and migrated to .NET very early on, actually after I saw one of the early alphas and was quite impressed by it. And I've basically been a C# and VB developer ever since. I've got a couple of Pluralsight courses out, and you might notice that none of that seems to have anything to do with Office documents. So why am I talking about Office? The answer to that is that quite often in my .NET coding, I've kind of needed to extract information from Word documents or Excel documents, etc. And the traditional way that most people do that is you discover the primary interop assemblies for Office and you start talking to the COM objects inside Word using that. Has anyone done that sort of coding? Yeah. Yeah. Has anyone actually enjoyed doing that kind of coding? Yeah, safe question that. You get an object model that kind of defies all imagination, almost no documentation, error messages that you don't quite know what they mean. It's not a pleasant experience. So a few years ago, I started looking around to see if there was anything better. And it turned out there was. There was this thing called Office OpenXML, which lets you access the documents using XML. I wouldn't necessarily say it's easier to use, but it's a much nicer, more object-oriented framework. And it's miles better for a lot of purposes than using the Office primary interop assemblies. For some reason, almost no one has heard of it. So that is kind of sums up the aim of this talk. The first thing is I hope you will go away with some understanding of what Office OpenXML is. Based on that, you will understand what is actually inside those docx files and XLS files that you save. And also show you a bit about the OpenXML SDK, which is Microsoft's way of accessing Office OpenXML documents programmatically. And I'm assuming that you can read C#, because there's not actually going to be a lot of code in this. It's mostly going to be looking at documents, but there's going to be a bit of code in C#. And I'm assuming you've used Office, but I think that's a pretty safe assumption. Is there anyone, by the way, who has actually used Office OpenXML quite a bit? That's good, because this is a beginner's level talk. And I was a bit worried if lots of people came in who already knew loads about it, you'd get a bit bored. So what we're actually going to do, we're going to start off by digging into some Office files and see what's in them. Then I'm going to explain what Office OpenXML is all about, show you how to do some coding with it, and then show you how you can use what you know to fix Office files, sometimes if you get problems with them, without actually using any code. But to start off with that, before I do anything else, I just want to think a bit about how you actually see. Now on this slide I've said Word. Everything I say in the next 4 or 5 minutes applies equally to Excel or to PowerPoint, but I'm going to use Word as the example. Now, if you are an ordinary user, and you can tell this guy's an ordinary user because he's looking really, really frustrated, to the ordinary user, Word is probably this blue icon on your desktop with a W in it, and when you click on it, it lets you write documents and edit files. And if you're really lucky, it lets you format them in ways that you don't understand, and then you discover that you can't get them formatted the way you do want. And if you're a casual user, you probably, you know that you can store these files, but you don't think much about it. You know, if you've got Windows Explorer on its default settings where it hides file extensions, you may not even know that these files are called .docx. But you know how to use Word, hopefully. On the other hand, if you are a .NET programmer, and you can tell she's a .NET programmer, she's looking smiling, she's happy, she's obviously enjoying her job. Yep. To a .NET developer, you have a similar view. Word is this thing that you bring up by clicking on this pretty W icon. You know a bit more about computers. You've got a bit more awareness that there is Word, the application, and there are these files that it stores. You also know that you can write macros using Visual Basic for applications, which is actually a really cool feature, especially like when you think how long it's been around. This word processor actually has its own development environment inside it. And of course, if you are a complete masochist, you can start up Visual Studio, talk to those interop assemblies, and you basically talk to the same COM objects that you would use inside Visual Basic for applications. And notice at this point, you're not actually talking to the back-end document, you are talking to Office, the application. Now, if I compare that with the traditional business application, you know, the well-architected one, which I'm sure you all pretend you write, but deadlines get in the way, of course. I'm only joking. Typically, well-architected enterprise application, you've got user interface, probably several user interfaces, you know, maybe WPF1 for your admins, a web interface for the users. Completely separate from that, you have your back-end business logic, and that's probably a different component, you know, with some standard means of talking to the user interface, maybe an API that plugs into that. And you've also got the data store at the back, which I know you don't normally do it, store it in floppy disks. These days it's a SQL database, but that is the prettiest picture I could find, and I'm not one to let the facts get in the way of a pretty picture. So that's a typical enterprise app. Compare that with Word. Again, you have, oops, wrong slide. You have the back-end data store, which in this case is a .docx file. And you have a user interface and you have business logic. But they're both wrapped up in this kind of monolithic single entity and with an object model that plugs into it. That's not probably how you'd write an application these days, but it's, you know, how things were often done 25 years ago when Word came out. But the thing I really want you to notice of this is there really is this separation between the back-end data store and the application. You know, if you're using Visual Studio, using the primary interop assemblies, you're not really talking to documents, you are talking to the application. You know, if you like, what you're talking to, roughly speaking, like view models rather than back-end entities. And what Office OpenXML does, lets you do, and what I'm going to talk about in this talk, is this back-end data store, the actual document files. You're not going to learn a lot about Word or Excel or PowerPoint themselves. You're going to learn about what actually powers their documents. So I said we're going to dive into some documents. Let's do that. So I seem to have this slightly awkward thing that I can't actually persuade that to show me not the slides unless I actually close the presentation. Which I don't really want to do because I know it's a pain to bring the slides back, but we'll have to do that. So, I have a folder. I am going to create a Word document. So, new Microsoft Word document. let's call it welcome or something. And I'll say, hello, nice people, and make that a bigger font so you can see it. Is that big enough for people at the back? Okay, that's cool. So there's my personal message to you. Hello, all you lovely people. And let's save that. Very simple Word document. And if I say I'm going to open that up and actually see what's in it, that kind of sounds like insanity. Yeah, if I, let's say open with, let's just actually show it to you, open with Notepad. And it looks like binary garbage. You know, it looks like not the sort of thing you'd want to play with. Except there's some rather odd things. Look at this word styles.xml. There's something interesting going on inside that. And what it actually is, these files are zipped XML documents. And I'm going to prove that because what I'm going to do is I'm just going to start by taking a copy of it, just so I can, this is the original, so I'll paste that. And I'm going to go to my original one, and I am going to rename it .zip. And Windows is now telling me that I am doing something very dangerous. The file might become unusable. Yes, I'm going to be a devil and go with it. And now Windows Explorer thinks that that is a zip file. So if I double click on it, it's going to open this as if it's a zip file. And look at that. It's got folders inside it. So I'm going to put on my what looks interesting hats. Let's explore it. There's a Rels folder, there's a docprops folder, Word folder, rather uninteresting looking XML file. I'm going to guess that Word is the folder that has interesting things in it. I'm not really guessing, I've obviously done it before, but hey, let's pretend I'm being I'm an intrepid explorer. And look at that, more folders, Rels, theme, and some XML files. Font table.xml, settings.xml. Well, I'm going to guess that document.xml has got interesting stuff in it. Obviously, this is a complete guess. I've never done this before. You all believe me, don't you? And inside this XML file is, wow, loads and loads of namespace declarations. And look at this. W before, know how XML works, anything before a colon is a namespace. So that is a body tag, sorry, a body element in a W namespace. That has a P element inside it, something called ppr. And there's what I put in the Word document. Hello, nice people. Inside, well, T, I will tell you, is text tag. R is run. The way this works, basically, Microsoft does not want these documents to become oversized. They are very concerned about keeping documents as small as they can be, for obvious sensible reasons, which is why you see all these names of the elements are like one letter, and they're using like one letter to mark the namespace. So that, in short, is what a Word document is. It's a zip containing lots of XML files. So you really don't need Word, the application, to open it. You can just look at it as if it's XML. And if we look at let's close a few elements up and get a bit of a better idea of its structure. So the interesting thing here is this P, oops, what's going on there? Element. So you have a body, P, any guesses what that's likely to be?
Paragraph.
Paragraph, yeah. just to make sure you're still awake, because I know it's the very last talk on the last full day of the conference. And then inside here, P+. So thinking caps on. What? Any guesses what that will be?
Paragraph properties.
Yeah, that was. I believe that was a guess. Yeah. Again, it's Word being very kind of using as few characters as possible. That's properties that apply to the whole paragraph. And then you've got this thing called R, and that is what's called a run. And does anyone use WPF documents in that? I'll take it no. It's very similar to WPF. What you have is text. If you look at this Hello Nice People, you'll notice that is in a T, which is text element. That has got, text can only contain text, nothing else. A run is basically a set of text that has certain formatting properties. So if I say wanted to make people, a bigger font, I would have to have a separate run for that. And then runs also have their properties, RPR for run properties, which file is 56, so that's where I made the font bigger so you could all read it. This RCID defaults I wouldn't worry about. That's basically information about when the file was last edited. So simple Word document, that's what's in it. And I realise I've probably spoiled your working day now, because you're going to go back to work tomorrow or Monday. Your manager's going to send you a document. Instead of just opening it and reading it, you're going to be like, ooh, rename it as a zip file. Let's explore what's in it. And if I just go back to the slides and... What have I done with my PowerPoint? Oh, there it is. Yep, so that's space. Actually put it on the screen. So that's the basic structure of a simple document. You've got the document, you have a body inside it, paragraph. The paragraph has properties. Inside a paragraph you have a run. Then inside a run you have run properties and text. It's very simple documents. You can get a lot more complex than that. And I just hit escape and I didn't want to do that. It's gone. So next, relations. I just want to show you a little bit more rigorously what happens. Because when I go into this document, so I have my zip file. And when I went into it, I saw these folders. Now, I kind of said, Word looks like the most interesting thing. That's kind of, because I'm a human being, I can read English. If I was a computer program, I wouldn't be able to do that. So, if we want to look at these programmatically, you need a more kind of structured way of approaching it and seeing what's in it. And what happens if I was a C# program, not a human being, I wouldn't go to this Word folder first. The first place I would go to is this Rels folder. And what happens is this whole document is actually referred to as a package. Inside the package are various parts. It looks hierarchical because it's got folders in and it's got XML files, and you think of XML as hierarchical. But it's not. It's actually more relational in nature. It's a bit more like a relational database. And what happens if I go in this Rels folder, click on .rels, what I have is an XML file that tells me what the relationships are. And by relationships, it's like how the different parts of the document are related to the overall package. And if I take, say, the last one, because I happen to know that's the most interesting one. What you've got, the relationship, target, that tells you what file this part is going to be in. And the type looks like a URL, but it's actually an XML namespace. You know how XML works, the namespace is always given by URLs. So you've got this HTTP schemas, blah, blah, blah. And if I actually went there in a browser, the browser would probably say, what are you doing? There's no such URL. But the standards say that this particular URL, ending in Office document, is the thing that says this is the document itself. So if I was a program, I'd go there, look for the thing with that namespace, look at the target, word./document.xml, and I know that's where the document is. It's also got an RID1, in case anything wants to refer to it. And there's two other targets here. There's a thing called app.xml and core.xml. Those are basically the document properties. I'll show you those in a minute. In fact, I will... Yeah, if I quickly look at .props, those are the app.xml and core.xml that the relationship sends you to. Core.xml is basically just things like who created the file, when it was last modified, etc. The difference between core and app is that core.xml are any properties that apply to any document, whether it's a Word one or an Excel one or a PowerPoint one. App.xml is specific to what's called the application, which in this case is Word. So that's got things like how many pages there are, how many words are in it, the kind of stuff that would be irrelevant if this was an XML document. Sorry, if this was an Excel document. Get that word? But let's imagine we want to look at the document. So we go into the roles file directed us into this folder. And look, there's another _roles folder in that. This one tells you how things are related, not to the package, but to the document. So this document.xml.roles, this tells you anything that has a relationship with the document XML file. So things like the font table, because if you want to look at the documents, you need to load the fonts, the styles, various settings, that kind of thing. So the takeaway from this is that the whole thing is relational. It's based on relationships between parts. And if I go back to the PowerPoint, this is kind of, in part, how a document looks like once you get to the main document. You've got the document, there's all the sorts of things that you might want to look at in conjunction with the documents. Footnotes, footer, fonts, styles, comments, header. Footer, by the way, is just anything that goes at the bottom of any page. Footnote, on the other hand, is like if you want to make a comment by some text which goes at the bottom, but it's not the same as a footer. Now, the way I've drawn it, that looks hierarchical, but it's not, and I can prove it's not, because I can add another thing to it, which is the glossary document. Glossary documents, you might not be familiar with, is in Word, the package, there is a main document, which is what you normally see. The glossary document is basically like for snippets of text that you might want to paste into the main document, and you keep them available in the document, but Word doesn't normally display them. But what you can see is the main document is related to the glossary document. The glossary document is also related to all these same items that the main document is. You couldn't get that kind of relationship in a hierarchical situation. But To move away from the logical relationships and look at what the file, the zip file, looks like, you start with a package. In Office OpenXML, the thing at the top, the actual file you're dealing with, is called a package. There are relations, there's a document part to it, properties, and below it in the file hierarchy you then have the main document. That has its own relations, which are then related to other bits of it. So that's the basics of documents. I'm just going to show you a little bit more detail now. If I do this and that. Oh, that's evil. Even if I minimize the PowerPoint presentation, it still just shows the PowerPoint. There, right.
Is the layout the same for Excel and PowerPoint then?
It's very similar. I'll do those in a little bit. But the principles of it, the fact that you've got relationships and roles, folders, that's the same. But the actual content of it is going to be a different XML schema. So I'm going to go back to our Word document, not that one. I go back up to the top. So here's my document. I will rename it back from being a zip file. Let's open a couple things. If you change a file name extension, the file might become unusable. Yes, I want to change it. Come on, copy. I just want to show a couple of other things in it. Let's say I'm going to put the name DevWeek, because you're all here from DevWeek. So hello, nice, lovely DevWeek people. And I'll just put that and save that again. And it doesn't look like I've changed much in there. I've just added another word. So I will take a copy of that. Copy. Paste. Do the same thing again, rename it. If you change a file name extension and it's worked the last couple of times, I trust it's going to carry it on working. Let's go into it. Let's have a look at the document again. Scroll down. It's changed. You don't have hello, nice DevWeek people anymore. If I try and close it up, let's close up this run, close up the paragraph properties. We have a run. Let's get rid of the run properties. Hello, nice, all in its own run. And the space equals preserve. The reason for this space equals preserve is because you've got hello, nice with a space after the nice. And the way XML works, white space is ignored unless you tell it not to ignore it. So that space equals preserved. Make sure that that space will be there in the Word document when you load it. But then after hello, nice, we have proof error type equals spell start. And then DevWeek, all in its own run. Then another proof error thing. And then if we, apparently another run that just has a space in it. And then another run with people in it. And then you have two bookmarks. And there's a few things we can deduce from that. One is that Word is not especially intelligent because it's put a bookmark and then immediately ended the bookmark. And then there's this spell start and spell end. And what that is about is if I go back up and actually have a look at my copy of the document. there's this squiggly red line under DevWeek because Word doesn't recognise it as a word and it thinks that's probably a spelling error. So that tells us that spelling errors aren't just in the application, they are actually persisted to the underlying document. But there's something else, because if I wanted to mark a spelling error, wouldn't you just create an element to say spelling error and wrap it around the bit that's got the error in it? That would be the sensible way of doing it. But it hasn't. You've got an element that says here's the start and an element that says here's the end. Which seems odd, but the reason it's done that is because suppose I did something like this. Suppose I took this Hello Nice DevWeek people and I took part of DevWeek and part of people, and let's say I reformatted it. Let's say I make that a lovely shade of green. Now, if Word is going to be able to store that in the XML, it needs a run to cover Hello Nice Dev. It needs a separate run to cover week P, which is probably not going to help my reputation, so I'll actually just let us change that and actually make all of week people green before I end up making noises out of regret. So you have a run that starts there and covers week people, and you have this spelling check that covers DevWeek. And that's a bit of a problem because you would have a spelling element that overlaps the run. It starts in the middle of one run and ends in the middle of another run. You can't do that in XML because in XML elements have to be contained in other elements. So the way Word gets around that is by not having an element for spelling errors, but by having an element that says where the spelling error starts and another element for saying where it ends. And that's a common thing, again, you'll find in Office documents. You see elements to mark the start and the end of something instead of elements to mark the entirety of something. Let's do a couple of other things with this. I'm going to take people, let's put a comment on it. Where's my insert? Yeah, new comment. Let's say, maybe I want to send this to America. I think in America they quite often say folks rather than people. So let's put a comment saying, should that be folks? Sorry, that's probably a bit small to read, but that is just saying Simon DevWeek, who I am, and the comment, folks. And that. So there's a comment. And let's put an image in it. Funnily enough, I have an image just ready for this, which is the DevWeek logo. Lovely, I love that logo actually. Great. So now I have a slightly more complicated Word document with picture and comments and other stuff in it. Let's save that. And again, let's go back to code demo data demo where I had that. Here is, I think it's the file welcome copy that I just edited. So let's go to the old zip file. I'll take another copy of that and I will rename this to .zip so I can look inside it. And sooner or later I'm going to dive into Windows and find where this dialog comes from and kill it very slowly, I think. We should go in. There's Word. What's in the document now? Ooh, it's got a lot more complicated. In fact, first I won't show you the document. I'll show you there's a new folder appeared called Media. Look at that. There's an image inside it. And that's my image. So when you put an image in a Word document, it doesn't do anything to the image, it just sticks it in the zip file as a file in its own right. Which is very nice because it makes it very easier to look at them and extract them. Let's go up and look at that. There's more stuff here. There is now a comments.xml that wasn't there before. And obviously if I open that, that's going to have the comment in it. And there's a couple of things going on here. So there you've got hello nice. Spelling error should start there. Week, you've got people. And notice you've got comments have been treated exactly the same way as spelling errors. There's no element for comments. There's a comment range start to tell you where the comment starts, and a comment range end to tell you where it ends. And again, that's to make sure you can put comments anywhere. What you've also got here is this is very modular. And if I go back to these slides again, oops. Package parts, actually looks like I've got a bit out of sync with. Okay, I can't find the right side. What I will tell you, what this is about, the whole structure of documents is modular. If I really wish there was a way of swapping between slides and other stuff. If we look inside that document, there's loads of different files. Now the idea of that is that if you want to look at just part of the document, you don't have to open the whole thing. Let's say you've got, for the sake of example, say you have a company logo that's in lots of documents. Your managers decide to change the company logo because managers like doing useful things like that. And so suddenly they tell you that you've got to change the company logo in all the company's Word documents. So you're going to write some code to do that. You don't need to go and look at the document XML to do that. You can just open each package, go straight for the media folder where the images are, and change the images. Let's say the fonts, the company styles change, so you've got to change some of the fonts. You can open the package, drill down, find the fonts XML file, modify that. You don't need to touch the document XML file. So if you want to modify bits of the document, the fact that it's modular makes it very efficient. You don't have to load the entire document if you want to extract just some information from it. It also actually makes it quite robust, because it means if your code goes in and mucks up something in there, if it mucks up one XML file, Word or Excel can probably still load the package and load everything else and just do that. And I actually discovered this in fact a couple of days ago, because when I was preparing for this talk, I was kind of playing around with some images, and I kind of realised it was the wrong file after I deleted a couple of images. So I closed the file and went back to open the right file. And then yesterday I opened the the PowerPoint document for the other talk that I gave earlier this afternoon on .NET collections. And the first thing I saw in it was like the text for the opening page with the message, PowerPoint cannot find the images for this file. But it had still loaded the rest of the document absolutely fine. Luckily, I had about 3 backups of it in different places. Otherwise, that could have been awkward. So, we've seen Word. I want to show you XML and PowerPoint a bit, but first of all, let's actually talk about what Office OpenXML is. So, yeah. So what Office OpenXML is about, if you look back, say about 10 years or so, more than that, remember back in Office 2003, and before then, you didn't have docx files. If you had a Word document, you would save it as a .doc file. And that really was a Microsoft-specific, custom binary XML file. It's the sort of thing you would have to be insane to want to open. If you wanted to look at it, you would just let Word look at it for you, because Word understood it. In the 1990s, that was sort of acceptable. But Microsoft was coming to realise that people didn't want to use Office in isolation. They wanted to use Office with applications. You would want to write C# code and access Office with that. So they realised custom format was not good. And when Office 2007 came out, they changed all the file formats. And I remember at the time when it happened, I was thinking, why do Microsoft have to mess this up? I'm used to these files. What's the point of changing it? But of course, the point was they had realised, this format needed to be open. So they replaced it with the docx, XLSX, and so on, the zip to XML files that you've seen. But what's even better than that is they made it an open standard. Office 2010 and 2013 came along, not much change in that. But you now have this open standard, which Microsoft have submitted to ISO. It's a standard for document storage. It's Microsoft-led, designed for Office 2007. And I will say, don't confuse it with OpenOffice. There was this OpenOffice, the idea of doing an open source equivalent of Office, based again on zipped XML files, and that kind of collapsed and died and then forked into LibreOffice. Nothing to do with Office OpenXML. This is a Microsoft-led standard. It's ECMA 376. Obviously, I'll test you on those numbers later on. So you can look it up. You can go to that URL there, and you can look up the documentation for it. And what it covers is Word, Excel, and PowerPoint. Unfortunately, it doesn't cover Outlook. Why they didn't do it for Outlook, I don't know. The cynic in me thinks they were probably making too much money from Exchange and they didn't want to risk it. But maybe I'm being unfair. Sorry?
What about Visio?
No, it's just those three. So it's literally like the Office that you kind of see if you're an ordinary consumer, not the Office that you'd see, the side that you'd see as an enterprise person. But it's quite nice they've got those. What the standard gives you is 3 markup languages. One for Word, which is called the word processing one for Excel called the spreadsheet one, and a presentation markup language. Notice the terminology there. It's not called Word markup language, it's called word processing markup language. And that's a nod to the idea that it's a standard for document storage. If you want to write a rival to Word, you can do it and use the same format. There's also some common markup languages, drawing markup language. That's if you embed a rectangle or an arrow into Word or PowerPoint. That applies across all 3 applications, so it's got its own markup language. And there's some more minor markup schemas for maths, properties, bibliography, and so on. So just looking at the advantage of this is it's an open standard. As I've said, it's modular, which makes it very efficient and quite resilient. The disadvantage is it is designed around Office. When you look up the markup, it's obviously not done as a neutral, here is what a document would ideally look like. It's like, this is what we've actually implemented in Word and Excel, so let's put this into a markup language. So you can write, you could write an alternative Word or an alternative Excel using this markup language, but you're basically kind of slightly tied into the same features that Microsoft does. The other disadvantage is that it is open, but it's quite a task to read it because there are a lot of features in Microsoft Office. So I'm going to show you some shortcuts soon, but the basics actual schema is 5,000 pages long. And ironically, there's also actually a very nice introduction to the schema as well that they put in the document. And you would you think, where is the most logical place to put the introduction, the primer to it? Any guesses?
Should be beginning.
It should be, yeah. That's the exact opposite to where it is. So if you do download this document, which you can do from the website I gave you, you get this 5,000 page document. After you've read through about 4,500 pages of it, you come to the bit with is the primer. Read this first. So it pays to look at the table of contents in it quite carefully. But anyway, there's that. So that is, I've given you a bit of a flavour of how the SDK works, only for Word. I know I will do Excel and PowerPoint soon. I want to look at the SDK now. Because what you've got, I've shown you zipped XML files. I have shown you, exactly how you can read the files, roughly what the process is. It's all fully documented, as long as you don't mind reading 5,000 pages. So in principle, I'm pretty sure every one of you could write code to consume an Office document based on what I've said and a bit of reading. But you don't have to do that, because Microsoft have also released an SDK to make it a bit easier. It's an XML-based one, and I will just show you that now. So here's where you actually get the bit of code in the talk. Get rid of my PowerPoint again. Come on, yep. Windows Explorer back. So in fact I will just show you, because I have the URL saved. In fact, I have the URL for the standard saved, so if you go that's download the thing. Here are all the parts of the standard that you can download and read. But if I go to the OpenXML SDK, this is a Microsoft site. SDK, there are lots of things. Oh, hang on. And I should be at a page that says, please download that. What's happened? Oh yeah, download. It's Thursday afternoon, it's the final day of the conference. That's my excuse. Choose the download you want. There's actually two things to download. You've got the SDK and the tool. And if you're going to do any work with Office OpenXML, you want both of them. Let's just show you what you get if you actually do download it. I get a thing, v2.5, it's currently at version 2.5. There's no indication they're going to do a newer version, so that's probably the version for the time being. First look at lib. This is the SDK, one DLL file. So a lot nicer having that than having to put the entirety of Office on your machine if you want to read Office files. And then you have this tool, and I will show you the tool first. Now I apologise, I don't. Oh, I can change the fonts on this. Let's just make the font a little bit bigger so you can see it. Make it 16. Shall I make it 18? So what I can do is I can open a file. So open. Let's go and find my DevWeek stuff. Talks. Open XML. Later demo. So here's that welcome file that I made, my docx file. If I open that in the productivity tool, I get a view of the XML. So I can say, look at the document. Now, if I need to click on Reflect Code, and this is doing a couple of things for me. Firstly, in the top of this, you've got the actual XML. So it's the same XML you saw earlier, body, paragraph, and so on. In the bottom, you have got the C# code that you would need to run to generate that bit of XML in that Word document. So before we even know anything about the SDK or how it works, you've actually got this code generator that you can say, okay, here's a document, give me the code to create this document, and it will do it all for you, which is, I think, is pretty cool. The other thing it does is, remember I showed you all this relational thing where you've got to look at the rels folder and work out from that where the files are. The SDK and this tool understand that. They will do that for you. So what you see here is just the XML files. The tool knows how they are related to each other. So you don't need to worry about how the file structure works. So if I drill down, I start off with the file, the package as it is. I have the document part. This square brackets here kind of tells me that's a part. It's a bit confusing because a part is just an XML file, but the part is considered to contain the XML file. Under this, I have angled brackets, which means that is the XML file for the document. Under that, I have body, paragraph, everything. And so I can look at the reflected code, the code to create that. I can look at the document. The other thing I can do, if I go to Actions, View Documentation, I've got two things that are useful. Firstly, I've got the API documentation for the particular classes in the SDK that represent that element. So in this case, paragraph. The SDK contains a paragraph class that represents paragraphs. Got the documentation for that. And even better, under file format reference, you have got the standards documentation for that XML element. So you don't need to read all 5,000 pages of the standard. You can just navigate here and it will show you the documentation for what you're looking at. So in this case, you've got P paragraph. This element specifies a paragraph of content in the document. Typical documentation's very dry reading, but it's all there. It tells you what the attributes are, what child elements can be in it, and so on. So, very nice tool. If you want to do anything with Office OpenXML, use this. There's something else here, because let's look at this document again. Here's my DevWeek. So go back to the thing. Open my copy document with the image in. Now, this tool generates the code to create any given element, can I just create an entire document with it? Well, let's try this. I'm actually not quite convinced I'm looking at the right file here, so I'm just going to close it and reopen it. The one problem with it is that because you're seeing XML, you can't really easily see what's in the file. So I want this document with its bit of text and its nice image in. So let's reopen the tool. Open SDK tool. Grab that, open file. Just make sure I have actually got that path. Yep, I think that's it. So let's keep the top level node and click on reflect code. And this presumably is the code to generate the document. So let's go to Visual Studio. I'm going to create a new project. Make it a console application. Generate doc. We'll give it that name. And let's just make a new class. In fact, if I look at the tool, the code it's telling me has got loads of namespace declarations, and then it's giving me a class called generated class. So I'm going to Control A that, select it all, go back to Visual Studio, and I want to create a new file, add class. I'll call it generated class, and kill everything Visual Studio has given me and paste in what the OpenXML SDK tool has given me. And you've got lots of namespaces it doesn't recognize. That's because I need to add the right references to the project. Any OpenXML document, sorry, anything that uses the OpenXML SDK needs two references. Firstly, it uses Windows Base, which comes from the .NET Framework. And also, you need Office, the SDK's own DLL, which is called document format.openxml, which is in my recent, because I've used it quite a bit before. So let's add those. And hopefully that's, is that added? Am I going to be defeated by the fact that the dialog box is too big? Try again, add reference. Recent. I'll add both of those. Aha, that's my OK button. Okay, so that's cleared up the namespaces. And if I just look down this generated code, well, there's an obvious method called createPackage, which takes a file path. So fair guess that's the one I want to call. So I'll go to my main program. I want to new up the generated code. Let's call it generator equals new generated code. Lovely intuitive name the SDK has given me. Actually, sorry, it's generated class. And I reckon there's a namespace missing there. This is in namespace generated code. Obviously, in a real application, you would fix this up. I'm just doing it quickly, so I'll add a using declaration to grab that namespace. Using and we have that. So now let's call generator dot create package. I just need a file path, so let's go back to the folder I'm using. Copy in part of that folder, and let's say created by SDK .docx. Let's run that. Builder. I was just thinking, after all this build up, if there's any build errors, this is going to be really embarrassing. What is it complaining about? Semicolon expected. That could be the problem. Try again. Seems to have run. Look at that, I have a new Word document called Created by SDK. It's even got the image in it. How on earth has the generated code given me an image like that? Well, let's go back to the tool and have a look. Let's drill down. Media image1.ping. So this is going to tell me what the code was that gave me the image. Hash region binary data. This tool has actually converted the image from the document into binary data to go in the C# source file, which I'm not quite sure whether to think that's impressive or to think someone at Microsoft must have had too much time on their hands, because that's not quite an essential part of an SDK, I'd have thought, but it's pretty good. So we've gone an awful long way without doing any coding, haven't we? But I think it's about time we change that. I'm going to kill two birds with this. First of all, I'm going to show you a bit about the XML file structure, and then I'm going to do some bit of coding to read an XML document. So, let's get rid of this Word thing. Go back to my folder with all these Office documents in, and I'm going to create a new Excel worksheet. I'm going to give it a... In fact, what I'm going to do is I'm going to imagine that I'm sending my report to DevWeek on how popular this talk was. So I'm going to call it DevWeek report.xls. And I'm going to put the number of people who attended this talk in. So it's my name, Simon Robinson. Is that visible, or do you want me to make the font bigger? It's all right, cool. Of course you're going to say it's all right, you're sitting at the front. But that's good enough for me, it means I don't have to change anything. So I can't be bothered to type in the name of this talk, it's so long. I'm going to call it the Open XML talk. And I reckon there's about 5,000 of you in the room. Sorry, I missed you over there. It's 5,001. And then do the same for my other talk, which was .NET Collections. That wasn't so popular. There were only 4,000 people in that one. Let's Just can't get the interest in .NET these days. So I shall save that as my report to send to the DevWeek guys. Let's do my usual thing. I will copy and paste it. DevWeek report copy, just in case I want to look at it in Excel. And I will take this DevWeek report and rename it as a .zip file. If you change a file name extension, the file might become unusable. I think my next talk is going to be 1,000 ways to kill dialog boxes very painfully. For them, not for me. Right, go in that. Quite a familiar structure, isn't it? So you've got a rels folder, .props, and instead of a Word folder, you've got Excel. Now it gets a bit more complicated. We have workbook.xml. What's in that? Some namespaces, not a lot. But you have a thing called sheets. Sheet with a reference and a name. And that's because Excel has a bit more of a complicated structure than Word. Remember, in Excel, if I actually open the document, this is where I'm really glad I took a copy. You have the whole workbook, but you can add sheets to it. A workbook can contain lots of different sheets. So inside the workbook, you have worksheets. But this is OpenXML, it's not hierarchical, it's relational. So what you've actually got is a workbook which is related to worksheets. Let's drill down a bit more. Let's go back in there, Excel. Of course, there's a folder called Worksheets. Let's go in that. Sheet 1. I think it's a fair guess that that's the worksheet that's got the data we want. Have a look. Whoa. There's a bit more. So we have sheet views. I'll ignore that. Calls. Sheet data. Oh, look, there's a row. R equals 3, so that's probably saying this is row number 3. C is actually a cell, and R equals, you've got the cell reference. R inside a cell means a cell reference. So cell reference A3, B3, and so on. And look, there's a 5001. So if we home in on just this element, we have cell C3 contains 5001. Check that against our actual document. C3, 5001. Anything else? Ah, look. C4 contains 4000. Yeah, that's good. So now I'm looking for something that contains Simon Robinson and something that contains OpenXML. And doesn't seem to be there. We've got a bit of a problem. And what's happened is we look at this document again. Notice I've got Simon Robinson down there twice. That's quite a common feature of Excel documents. You know, you've got a header or some data that says what's in a row, and it appears in every row. If I had 2,000 rows, if I'd given that many talks, there'd be Simon Robinson 2,000 times. Not a very efficient way of storing it if you've got 2,000 Simon Robinsons in the document.
Too bad when you zip it.
Sorry?
It's not too bad after you zip it.
Not so bad after you zip it. That's very true. But Microsoft evidently thought they didn't want to do it this way. So what they actually do is if we go back into this, go back to my zip file, look, in the workbook, there is a thing called shared strings. And what happens, look, there it is, Simon Robinson, OpenXML.NET collection. every string that appears in the spreadsheet goes into this shared strings document. And in the actual spreadsheet, let me have a look at row. Let's look at row A3. Now, row A3 contains Simon Robinson. What the XML has got is T equals S, which means this is a string, value of 0, which means this is index 0 in the shared strings table. So that way they do it so every string only appears once. That's our first bit of learning about Excel.
But the string table doesn't actually contain the anything, it's just serialization.
Yeah, it's just implicit. There's the... Yeah, if I look at the shared string table, you just assume that the first one has index 0 and the second one has index 1. So you kind of treat it like an array. And you've got that space equals preserve again because OpenXML, I must have put a space after it when I typed it in Excel. So that's pretty good. So let's try some coding. So now I've shown you a bit of what the structure of an Excel document is. Imagine a sample where I've imagined a situation where right, I have some test data. What I'm imagining is that we work for a company where every day they produce a spreadsheet telling you what the sales are. So this tells me that total sales on 27th of March were 111 somethings. Don't care what the something is. I have another spreadsheet. Let's close that one. I have another one for the 28th of March, telling me that on the 28th of March there were 130. And to keep this thing simple, the total sales are always in column C, cell C3. And we want to write a little program that just automatically reads the spreadsheets each day, works out what the incremental sales are. So it's basically got to read C3 from one spreadsheet, subtract it from the C3 from the previous spreadsheet. And I have some code that does most of that. I go into my code store. Here is a solution called Get Recent Sales. And it starts off with the main program. All I've got is I've got a main function. Let's copy. I don't want those. Right, I declare two hard-coded file paths because obviously hard-coded paths are great. Best way to program. And then I want my result, and I have a class called sales data reader, a method called get sales, and I pass in the two file paths, and then write the result out. And if I go to this get sales method, what I have another method called extract sales, which takes one file path. That return works out what the sales are from the XML document and subtracts one from the other, and that should give me the incremental sales. The only problem is that I haven't actually written the extract sales method yet. So this is probably not going to work if I run it. And I've done that because I want to try and show you how easy it is to actually get something from an Excel document, even without knowing too much about it. So, I've declared two namespaces. OpenXML.packaging is kind of the thing that does a top-level package that contains the parts, like the workbook part, or if it's a Word document, the document part. OpenXML.spreadsheet deals with things specific to spreadsheets. And I haven't just said using that, I've said using P equals packaging and using S equals the spreadsheet one. And that means I can just type P dot and actually see what's available, which will make the code a bit easier. So I'll throw in a bit of information to start off with. Oops. Using their package equals. And in the packaging namespace, there is a class called spreadsheets document. And there's obviously analogs, word processing document, or presentation document. And that has an open method, which I need to provide a file path, so file path. And it can also take a Boolean, which tells me whether I actually want permission to edit the file. And in this case, I'm just reading, so I'll say false. So everything in a using statement, so that will take care of closing the file for me. So I have my package. What do I want from it? Well, in an Excel spreadsheet, the package contains a workbook. So let's see if there's something called, oh, look at that, workbook part. That looks hopeful. Under the workbook part, well, there's going to be worksheet parts. Worksheet parts plural, because there's potentially more than one worksheet in that. So what I'm going to do, I'm going to put this on separate lines. And I'm going to do some link here and assume it's enumerable and just say I want the first worksheet, simplicity. Now, obviously in real code you wouldn't quite do this, you'll be going through this checking for any nulls returned, but I'm a speaker, speakers are allowed to do bad things with code. So this hopefully has given me the first worksheet. Now, if we look in our XML, let's go back to, that's the shared strings table. This is the worksheet. Everything was contained in an element called sheet data. Under that there were rows, and under that there were cells. So if we want to drill down, the next thing we want is sheets data. So package dot show. That's not looking too good, is it? Let's try data. Data part reference relationships. That doesn't look like what we want either. So we've hit a bit of a problem. There doesn't seem to be a variable to do that. And the key to this bit is that what these types in the SDK are actual. The SDK doesn't give you sort of high-level types that represent things directly like worksheets and that. It gives you types that represent the XML elements. So as I'm drilling down, all these things are types that are kind of derived from a class in the framework. I think it's called an XML container. So if I can't find a property that gives me what I want, I'll just use the fact that it's XML. And there's a thing in there called descendants. No, there isn't. Parts. No, I know. I am misleading you. The problem is it goes back to this thing I said, there's a separation between the part and the XML document. Even though they're the same thing, there's this conceptual separation. So I had the worksheet part. I actually need to get the worksheet from that. So now I have the worksheet. Now I can look for, there actually still isn't a data sheet part. On this, I can now look for the descendants. And let's just go for descendants. Maybe there is something of type cell. Yeah. So that will give me all the cells. And because that gives me all of the cells, I need to find a particular one. And let's do a bit of link on it, because we know that the cell we want is the one that has reference C3. So let's do where, and C dots, is there a reference? There's a cell reference property. You've got equals C3. So now I have the right cell. I need to extract the text from it. No, I don't. I actually need to do first on that again, because where gives me an enumerable. So another dot. Ooh, cell value. That looks hopeful. So I think that probably means I've got the value of the cell. What type is value? It's a type cell value. I haven't quite got there yet. In fact, let's have a little look. Remember again, this is an XML representation. So if we look at the inner text of XML, standard property of XML objects, the thing inside the element. Now, hopefully, value is a string, if I use IntelliSense. So I have a string, so now I just want to parse it as an integer. So int result equals int.parse value. Notice my careful error checking here. Return result. So that looks like it's worked. Let's build it. It's compiled. Oh dear. And actually, I think I know what's happened. System.io directory. What's happened is I tested this on my desktop, and remember how I told you hard-coded paths are really great, aren't they? But they're not so great when you run code on a different machine. Let's find out what the file path should be. So I put the files in that folder, test data. Now, if this doesn't work, this is when I get embarrassed. I'm embarrassed. System.io expression. File is being used by another process. It's because I have them open in Excel, and of course Excel always locks anything that's open. Do I want to save it? No, I don't think I want to save it. Right, now if this doesn't work, I'm going to be embarrassed. Phew, 19. Let's just double check that. The 27 folder had 111. 28 had 130. There you go. So that is how easy it is to code with OpenXML. And I would say it's 25 past 5 now.
How formulas?
Good question. Let me show you that. Let me put the formula into that. So let's say this equals, let's say sum of, I'll make it that and the 2 cells above it, which obviously is just going to be 111. And let's save that. And this is the 27 spreadsheet I've got. So we will do our rename into .zip. Go down into worksheets, sheet1.xml. And we are interested in, I think it was cell C4, wasn't it? Because it was the one below C3. C4, there you go. In fact, you have two things. You have the formula, F means a formula tag, and the thing actually is just plain text. So what you write in the formula gets directly saved in the document, along with something else, which is the value. What Excel does is it saves the formula exactly as you've written it, and it also saves the value notionally so that it doesn't need to recalculate it when it loads it. So it's all pretty open. And given it's almost 5:30, I think that's probably a good time to sort of end this, unless anyone's got any more questions. No? And as I say, this is well worth exploring if you do want to do any work with documents. Just the fact that you don't need Office to be able to manipulate the documents as well. Okay. All right. Thank you, everyone.